So right now we're starting circular arrangements, and this is on page 19. Okay? All right. Suppose we have three people. How many ways are there to arrange them in a straight line? How many ways? Arrangements in a straight line. How many ways are there to arrange three people in a straight line? Yeah. Jason? Sorry? Yeah, or 3 factorial, and that equals 6, right? Okay, I'm going to call those three, person 1 is going to be A, then B, then C. Now let's look at what happens in a circular arrangement. So let's say if A sits there, B and C can sit there, right? Or if A sits there, person C and person B can sit there. Or if B sits there, A can sit there and C can sit there. Or if B sits there, C can sit there and A can sit there. Or if C sits there, then A can sit there and B can sit there. Or if C sits there, then B can sit there. All right. So far, so good? Okay. So when it comes to circular arrangements, what we really want to do is look at how people are sitting relative to each other. This is a relative issue. So let's look at person A, and I am going to just mark him off here. We're going to see how these arrangements happen relative to each other. Okay? So let's look at this. Can you see that B is to the left of A, right? B is to the left of A. C is to the right of A. Oh, here we have C is to the right. No, sorry. C is to the left and B is to the right. Agreed? Right? C is to the left of A and B is to the right. If A is sitting right there. Now if A is sitting here, C is to the left, B is to the right. If C is sitting here, A is to the left, and, sorry, we're focusing on A. Here, sorry, we're focusing on A. I always keep the focus on A. B is to the left, C is to the right. A is here, B is to the left, C is to the right. And for this one here, C is to the left, B is to the right. Okay, notice that this one, and this one are the same arrangement when we speak in terms of B and C being relative to A. And then we have this one, this one, this one. So really, these three are the same, and these three are the same. Now how do we adjust our calculations for arrangements in a circle? Well, this is what we do. We go, the number of people we're arranging, subtract 1, because we're arranging them relative to one person, right? So we subtract 1 and we take the factorial. So notice there's really only two different arrangements. So we go 3 minus 1 factorial equals 2 factorial equals 2. There are only two different arrangements. Okay? So if you had 7 people in a circle, you would just go 7 minus 1 factorial. That equals 6 factorial, which I believe is 7. 20 different arrangements. Now we have one more circular arrangement that we want to look at, and that is items such as a necklace, a keychain, or a bracelet. Now, the thing about a keychain, for example, okay, let's say I have a keychain with 3 keys. I'm going to represent them by a circle, a triangle, and a rectangle. Okay, so what happens is, do you notice if I were to flip, the thing about these objects is you can flip them. You can't flip people in a table, because if you flip people in the table, the people will fall out of their chairs, right? But for a necklace, a keychain, or a bracelet, you can flip. You can flip them and your diamonds or your keys don't fall off your keychain. So what do we do for that? Well, notice when I flip, if I were to flip this over, the square key would come here, the round key would go there, and the triangular key would go there. So these two arrangements look different, but they are really the same. So to account for this, we go, again we fix one, n minus 1 factorial, and divide it by 2. So how many ways are there to arrange 3 keys on a keychain? It would really be 3 minus 1 factorial divided by 2. There's only one way. Okay? Good.